Hey guys, imagine the most obnoxiously strict science teacher. The teacher that deducts points for not rounding to the correct fourth decimal place and makes you wear goggles to stir sugar water. Now imagine someone who that teacher would hate for being annoyingly precise. That is the type of person that works for the Bureau of Standards and Measurement. Most countries have a standards bureau whose job it is to measure everything, from how long a second really is to how much mercury you can consume from bovine livers. To scientists who work at a standards bureau, measurement isn't just a practice that makes science possible, it's a science itself. Progress in any number of fields depends on our ability to make ever finer measurements based on ever smaller scraps of information. According to the Bureau International des Poids et Mesures, BIPM for short, just outside of Paris acts as a standards bureau's standards bureau, making sure all the franchises stay in line. One of the more peculiar jobs of BIPM is coddling the International Prototype Kilogram, the world's official kilogram. It's a 2-inch wide platinum cylinder that by definition has a mass of exactly 1 kilogram. Because the kilogram is a physical object and therefore damageable, and because the mass of the kilogram ought to stay constant, the BIPM must make sure it never gets scratched and never accumulates a speck of dust. The mere thought of the official kilogram gaining 1,000th of a gram induces ulcers in the Bureau of Standards type. So, like overprotective mothers, they constantly monitor the temperature and pressure to prevent microscopic expansion and contraction which could slough off atoms. It's surrounded by multiple glass layers to prevent humidity from attaching itself to the atom, and it's made of dense platinum to lower surface area to the dirty air we breathe. Platinum also conducts electricity which cuts down on the amount of parasitic static electricity, which in the BIPM's words might zap stray atoms. Due to platinum's toughness, it's also resistant to scratches on the rare occurrence it has to be taken out and used. Other countries have to have their own official kilogram so that they don't have to fly to Paris every time they want to measure something. The US has its own official kilogram that resides in a government building in Maryland. It's been due for another recalibration, but calibration is a multi-month process and getting through airport security with a strange piece of metal nobody is allowed to touch is a hassle. Even opening the kilogram's case in a dusty airport would ruin the calibration. There are 6 copies kept in France used to calibrate other countries' official kilogram. However, once every couple of years, the official kilogram must be used to calibrate its calibrations. Alarmingly, scientists have noticed a reduction of mass in the kilogram since the 1990s that adds up to the weight of a single fingerprint. What a catastrophe. The meter is a bit easier. For the past 100-ish years, scientists have been trying to come up with definitions of units that can be described using words. Something that you can read and then recreate to describe a unit. One such item is a meter, which is described as a distance light travels in 1/299,792,458th of a second. Similarly, the definition of 1 second used to be 1/86,400th of one spin of Earth's axis, which is the number of seconds in a day. However, the fact that the spin of the Earth is slowly slowing down each year makes this way of measuring a second less than ideal. To correct for this, meteorologists usually slip in a leap second once every 3 years at midnight when nobody's paying attention. But leap seconds are an ugly ad hoc solution, and rather than tie a universal unit of time to the transit of a big rock around a forgettable star, the US Standards Bureau has developed a cesium-based atomic clock. Cesium clocks work because their electrons are easily excitable. More precisely, they have a single electron in their outer orbit that when excited will jump in between 2 energy states. When it jumps from one energy state to another, it emits a photon of light. Each cycle of the electron jumping up and down between energy states takes the same amount of time. Today, 1 second is defined as the amount of time the outermost electron of a cesium atom takes to jump between its 2 energy levels 9,192,631,770 times. This was the first space unit that could be described and recreated through writing, and also helped to create the definition of the meter, which we saw earlier. So, in total, there are a lot of precise tools and measurements that scientists are still trying to perfect. And maybe one day we will have a universal precise measuring system scientists across the universe will be able to use. Bye everyone.
Okay, let's pour this bad boy